All right, time for another draftphysics.com, debatephysics.com video presentation to an audience of I want to stay in the matrix. I'm scared of the truth kind of people. The Protect the Dogma, Planet of the Apes. You know, the dogma is all that matters. The lies that you've founded your existence on, and there's no reverence for seeking the truth or the real, a real understanding of your place in this shitaverse, pushy shitaverse. Anyway, so I thought I'd just go over what I have acquired as a reveal over the last whatever 10 plus years of work, and just summarize, because there's no point talking to you. I'm just going to talk to people in the future. They'll find this in the rubble, I suppose, and say, well, look, if you're going to start over, don't start over with that nonsense, okay? Because that was all wrong. Unfortunately, there's no reason to start over because it doesn't go anywhere. It's all bullshit. Anyway. So, physics isn't, it's just a process of seeing things, events, and then trying to dissect causes. And it shouldn't be that difficult. So let's just start with Maxwell's notion, okay, that there's these two objects. That was the big discovery, frankly. Charge, plus and minus, opposite functions. So the likes repel each other, the dislikes, the dissimilars attract. Now, clear in this function is the idea of a magnetic monopole, because you would say, yes, that's exactly what the poles of a magnet do. Okay, the North Pole repels North Poles, the South Pole repels South Poles, and the inverse attract. So it would be kind of silly not to acknowledge that the electron and the proton, okay, so let's just call this a proton, and we'll call this an electron, are magnetic monopoles. I don't care. They don't, you don't have to believe it, but I'm just saying they're going to behave exactly as you would predict. So Maxwell's prediction is, okay, that these two things attract and the opposites repel. And the obvious conclusion you could draw is that, well, if I was to make something, if I was to let these things fly around in a pile somewhere, that obvious things would happen. That is, you could have one of these electrons, and it would be really, really simple. The idea would be simple, that a proton would be on this side and another proton would be on this side, because you could have complete attraction to the electron, and the protons can't see each other. Just a fact. I mean, a simple drawing, it just says, you could make this object. This object would be a makeable object. And then it would also be understandable that if in some way I could pop something out, like if I could just pop that electron out of that circumstance, I'd end up with two protons really close to each other. And we know the closer they get, the force gets more and more and more and more intense. And so they'd have a huge elastic potential to be flying out of there really quickly, both of them, because yes, they're going to repel each other strongly. So you're almost saying, why did they ever come up with some notion of a strong force, right? So this is the first big mistake, is to sit there and invent a fake force. No reason to invent, when you know it's charge that's building atoms. I mean, it's electrons and protons. There's no room for your muons, buons, suons inside of an atom, right? There's no diagram of an atom that has that crap in it, ever, that they'll draw. So it's just this charge function, which essentially is exactly the same as if you imagine these things as monopoles. So I could, instead of proton, I could just say South Pole, and for electron I could say North Pole, and then you could just understand it's just an arrangement of magnets. So now, this is what I did as a kid. You play around with this stuff, and then somebody shows you that you can put magnets under glass or something, where they can't flip. And so if I put magnets under a piece of glass, and I could have little north-facing magnets, and I could have a south-facing magnet, and I could, in fact, arrange them in such a way as they have their circumstances balanced. That is, their attraction is balanced by their repulsion. So this one can't move in because it gets closer to the north, and they push it away. And so everything just stays in a balance. And this is your first elastic kind of circumstance, because you could push on this. I could nudge it a little, put a little pressure on one of these south poles, and the other ones will react. And then when I let go and I stop putting pressure on it, it'll bounce back. They'll find their equilibrium again. So that's essentially what you're saying elastic is a circumstance where it has an equilibrium that is flexible. So you can disturb the equilibrium, but it restores itself. So you could argue that any time something reflects off another object, that what it's really doing is, it's breaking the equilibrium. The force impact breaks the equilibrium between these atoms and the electrons and protons. So the little electrons and protons are disturbed in their position, but they're elastic in the sense that they will restore that condition. They will have, the forces will want to push them back together, in the sense that you will start increasing forces between them. The increase in the force between them will push them back to their other state. So they will elastically react. So you can imagine the force can go in, and then the force will reverse and go back out. So, in a sense, the field of energy, the energy in the universe that's creating this circumstance, is the real cause of the effect. Now, that's what I would argue, is that if you wanted to think about these objects, again, you could just look at the Maxwell drawing and say, okay, so Maxwell figured out that it's completely proportional to me just drawing little lines on it, right? I could draw a number of lines, and you could just imagine those lines intersecting, so they crash through everything. And you just count how many lines, you're breaking. And obviously the closer they get, the more lines you break, the further away they get, the less lines you break. So it's a nice intuitive way, a simple way, it's not even intuitive, it's just simple, of measuring and seeing the effect. And we know that it really doesn't have anything to do with, we know that this effect is inversible, reversible. So there isn't like some sense that one is a going in force and one is a coming out force. They're both behaving as if they're just radiators. So if you take Maxwell seriously, it's just, this is radiating protonness, and the electron is radiating electronness. Now, just like a north magnet is like radiating north, and the south is radiating south. Now, the point to be made is that it's not radiating. It's not a machine. It can't produce it. It isn't eating any fuel. So it's not like a little Pac-Man that eats stuff and then, can poo stuff or shoot stuff or do stuff. No fuel, no way of doing that. And so the simple argument is that what these objects are doing is taking energy in a field, and all they're doing is changing it. They're having an effect on the field. So the magnet isn't producing anything. It's just reflecting. That is, stuff goes through it and is changed, or stuff bounces off of it and is changed, in the sense that obviously it's changed in its direction. So I can give you a simple explanation, and it's so simple that by default I think it wins, just because of the simplicity. So the simple argument is you have an electron or proton, you have the same thing in the field of force. So there's little arrows, there's little bits of energy moving the speed of light, and they have two features. One's red, one's blue, or one's square, one's triangle, one's, flat this way, and one's flat that way. Well, who knows? So they have two distinct features, just as the electrons and protons are distinct. And the simple argument is if I just take that field and have it equal from all around these two objects, and all I have to do is have one condition, it's there's what are the functions? So the function is what causes a reflection. So the simple argument could be the reflection is caused if the object is moving. Okay, say this was moving in this direction, and it hit a piece of the blue force, that the blue force would reflect, and this energy that was pushing it would reflect. So I said that a little more complicated than it needs to be. The simple truth is look, you have the electron. Let's say I hit it, okay, with a piece of this force. The force sticks if it's not moving. Now, if it is moving, okay, in the same direction, it sticks. But if it's moving in the opposite direction, so that if this was moving in the opposite direction, well, then it would be a conflict. This would reflect perfectly back where it came from, and one of the bits of energy that was stuck to it would reflect. Okay, so that's the simple principle. So you can understand both the absorption, that is, you can absorb energy if the object's moving in the same direction, and you'll reflect the energy if the electron's moving in the opposite direction of the force. And then the simple catch to the whole thing is, if electron force hits a proton, it just goes straight through and comes out a proton force. Okay, so with those two simple little things, that's simple diagram, it creates these two radiators. It means that this will always radiate blue energy. Well, that's my mistake there. Yeah, this will always radiate blue. Okay, because anything red will get turned into blue, and the blues will either reflect or be absorbed, so it's always radiating blue. And this will always radiate red. So the proton and the electron end up doing their Maxwellian thing. They end up looking just like Maxwellian charges, and they'll function again like that. And you can simply understand that it's just a matter of those things combining or getting close to each other to create atoms. So I guess we'll erase to talk a little bit about that process, and what the expectations would be. But it's so that simple diagram does work. All right, and that simple diagram is going to create a magnetic atom in the end, an atom arranged as if there were the electrons and protons were magnetic monopoles. And so it's not going to be swirling and spinning and doing all kinds of wacky crap. It's going to be locked in positions that are magnetically equalized. That is, the force attracting will be balanced by a force repelling. And so they're going to be squishy objects. Atoms are going to be squishy. Okay, so they're going to be like springs. They're going to be like rubber balls. So they're going to be able to store energy and release energy. And that, therefore, they're going to be able to reflect objects. And that's what we see in reality, frankly, and such. But I mean, it's you can just start with one statement by Maxwell, one drawing, and say, well, what's a reasonable way of getting there? How do I get to this point where you create two objects that are inversely functioning? And this is how simple it can be, and physics didn't even try. And again, this object is an inevitable consequence of Maxwell's drawing. You can't even evade it if you think about it just a tiny bit. You can understand that, well, these things have to see each other to repel. Protons can't repel protons without seeing each other. They do have a line of sight reality. So it has to be something they're excreting, this force. And so if they can't see the force, they can't be affected by the force. And so this would be an obvious consequence of the function. All right, I'll be back. All right, so another place that the physics went completely sideways is the Rutherford versus Bohr atom kind of notions and what a neutron is. So obviously I have played some clips from the past where there is a concession, okay, that physicists actually did say the words that a neutron, okay, was basically just a proton and an electron, all right, stuck together, that are a combined object. And when Rutherford described his nucleus, he had the electrons in the nucleus, so it did contain the negative elements. All right, so now modern physics, though, has just completely annihilated any kind of that notion. Now, even though they've sort of proven that neutrons decay, that is, when you put them out in some environment, that they will fall apart into these constituents of a proton and an electron. So, even though their own science concedes it, they still think of the neutron as something neutral, that it doesn't have any charge, that it's and obviously having both charges means, yes, you're overall neutral. From a distance, you're neutral. But up close, you're certainly not neutral. One side of you is polarized one way, and the other side is polarized the other way. So it just comes down to semantics and how you're going to use your verbiage. Obviously, from a distance, if I had a red and a blue object, from a distance, it would look purple. Right, and the closer I got, I'd be able to see that it had a red end and a purple and a blue end. Okay, so it's that kind of obvious. So a nucleus becomes a much more complicated thing if you're saying, okay, it's net positive because it has twice as many protons in it, okay, as electrons, and that would be the consequence, okay, of recognizing the neutrons as electrons and protons. So you could say, yes, it has 2 protons plus 2 neutrons. And that's basically how they calculate atoms. So you'd understand that this nucleus is, yes, it's net positive, but from certain places it's going to look net negative, okay? Because from certain places you're going to see the electrons. All right, and that makes sense to create the complexity of atoms themselves. But it just seems such a basic function. So if I took a neutron, if I took one of these objects where they're very close together, there could be a simple argument that, well, in this field of energy, there's always going to be vibrations. There's always going to be stuff hitting from this side and this side, the field, where there's little unevennesses, where something disturbed it, it's, got pushed an electron, so then there wasn't a reflection, so the field is not perfectly even. So there's going to be a lot of jostling. So you can understand that these two objects in a field that has some irregularity in it, okay, that's consistent over long periods of time but isn't consistent over a short period of time, you could understand that if these two objects are vibrating, okay, being oscillated and jiggled, that their capacity to stay together is limited, because they have to have this line of sight thing. And if they keep changing their location, it takes the field a little bit of time. So if they're moving at half the speed of light, jiggling, you could understand that if they change their position to a new position, it takes at the speed of light for these reflections and for this energy to get through and change. And so the force doesn't happen instantaneously. The force it happens at the speed of the force, the speed of light. So it takes a little time for a change in position to create a change in the force field. The field you're projecting at each other, the reflection. You are what you reflect. So just like this relativity argument where they try to pretend when you see something is when it happens, which is so ridiculous, you can understand that you're not seeing me at this exact moment. It is a little bit slowed down because you have to wait for the reflected light to hit me and bounce. And so it's traveling a longer distance. So theoretically, it's not now. It takes a little time for me to show up as an image. If I popped onto the screen, it would take time for the light to hit me and reflect into the camera. Just a fact. Now, it's a tiny bit of time from our perspective, but it's real from an electron and proton's perspective. It's a very big time. So you can understand why it's hard to get these things together. And then you could also understand that inside a nucleus, though, there's a bunch of these forces are all kind of controlling each other and controlling the balance. And so you could argue it's quieter in there. And so it's easier to get them even closer together because of the fact that all the force is being filtered through all these elements that are creating a kind of quietness. It's still a very intense amount of force, but it doesn't have the same amount of jiggle in it. And it's a simple enough explanation. So you can understand that, yes, hydrogen is a neutron. It just is a neutron out in the field that it's hot, you could argue. it's hot with an imbalance in the energy absorbed by the electron and proton. They just can't quite match up to each other because they keep changing their positions a little bit. And once they get to a quieter environment, they can get become a neutron. Viable argument, I'd say, in the construction of this thing called a nucleus. So a nucleus really is made out of this thing, this combination of a proton, an electron, and a proton. Now the argument is that from some measurements that they've done, which you'd argue they've really mismeasured the mass of an electron because they used mv squared and completely exaggerated the amount of energy the field had pushing the electron, and so they've got a completely wrong estimate of how hard it is to push an electron because they're using mv squared, and it's not going to give you a right answer. But clearly it does seem to be an indication that the protons are heavier, more massive than the electrons. Okay, now I'd argue they have to be the same size to create a balance between the two forces. The north-south, the magnet just as strong as the south side, blah, 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 blah. Those things would indicate that. And so the reason why there's twice the number of protons in the nucleus is because they're harder to move. They're heavier. So they need more force to interact with them to give them any kind of velocity, where the electrons are easier to push about. And so that's why there's that imbalance. But we know that the total balances. So we know that in the universe, the total number of electrons and protons are going to end up being the same, because we see that in the atom itself, in the sense that there's always usually a clear proportion between the numbers. And so, if I have 2 electrons in the nucleus, that is 2 neutrons, the number of neutrons will tell you how many electrons you're likely to have. And so it all rebalances out. And you're just basically arguing that, yes, the electrons are easier to move, therefore they're further on the outside, and that's creating the distinction here. And again, the nucleus is just net positive. It isn't all positive. So there's huge reason for electrons to be in certain positions relative to the nucleus, and that they wouldn't be in other positions. Like right here, you wouldn't find an electron because there's an electron showing on the nucleus. So this would not be a possible location for an electron to find any comfort. And obviously, it could also be understood that the electrons can't get any closer to the nucleus because they're always going to be able to see, eventually, that little bit of electron. And you could add spin here. You could say that the nucleus was spinning, and that would be even more reason why the electrons can't just fly into the nucleus, is because no matter where the electrons are in the nucleus, they're going to spiral into the location, will push the electron away a little bit. But the whole point is that we know this is all just geometry. So you're just saying you can have this simple geometry, to sit there and understand that if two things are opposing each other, that that triangle would be a possibility, or a square would be a possibility, to get equal distances from each other to balance the forces. And all you're saying is there's 100 of these geometries that work, that are durable in terms of where you end up placing electrons relative to the nucleuses. And the rest of them, if I try to fiddle with it some other way, I end up creating some radioactive element or something that's more likely to fall apart and deteriorate, because it won't be able to withstand interaction. Strange. Different pens. Anyway, so probably a break there, and I'll see if tie this segment up a little bit. All right. So the fact that nobody doubted the Bohr model, nobody thought about it and said, well, look, these are charged objects. They're not moons and planets around the sun. There's no reason to think they're going to behave like things that are not charged. Okay, and we clearly know that moon and earth aren't charged. It's not charge that's keeping the moon out there. It's a velocity. And that clearly charged objects don't need, okay, to use velocity to overcome something called gravity. You could even argue that there's no reason to think that gravity is a thing. They're charged. They already have a function. And the charge, I would argue, is what we call gravity with big objects. And we know that gravity is a big object thing. We know it's not a small object thing. It becomes infinitesimally small as a function the smaller you start making things. And so why would you think that's the significant factor, that something's gravitationally? No. You don't need any of that. So the whole idea of the moving, so again, it's a net positive, not positive nucleus. And, there's just no reason not to think that when two atoms are going to share an electron, that they're literally going to share it. Okay, that it's going to be in one position and the two nucleuses are going to be connected to it. Well, there was a mistake. Whatever. Minor. And that, the rest of the electrons will be around the object, and they'll, it's all going to, find a way to balance the pressure when it creates this new object. Okay, but it's going to be in a shared electron. It's both objects are going to be using it to balance their function. And it makes perfectly good sense, and it makes absolutely no sense that somehow they stay connected to each other and this thing is spinning in some figure 8 thing, and that they're somehow not colliding with each other, all spinning around an atom. It's just so wrong. And this magnetic drawing works so well. And again, it just, all you have to do is say, I can figure out that, theoretically, a magnetic monopole, if I was to make one, would look just like an electron and just like a proton. It wouldn't look like something else. It'd look exactly like them. So if you were to make monopoles, just invent some new thing called a magnetic monopole, and you stuck it in the environment, it's going to look just like electrons and protons. It's not going to behave any different. Same exact function as charge. It's likes repel, dislikes attract. I mean, it's the same function. So I mean, how could you see it any other way? That yes, it's essentially understanding them as a magnetic model works fine, perfect, no problem. And understanding that the forces can be balanced and that there are circumstances that make it there's enough noise in the system, heat, to keep the systems from collapsing even further. But that's what we sort of see. As you cool things, they collapse in 99% of cases. It's easy to understand the function in that way. I mean, the exceptions are things like water, and it just has to do with the fact that water isn't single atoms. They're connected atoms, and they create a shape that expands when it freezes rather than contracts. But anyway, because it's trapping other atoms, frankly, atmospheric atoms. It works fine, and it won't. They won't even say that. Look, there's other ways to do this. I mean, and they start off with this orbiting crap. I call it crap. It's just, I don't know why anyone fell for it. I mean, as soon as I heard it, I was like, what are you talking about? There's this complex orbits in here? Because they already told me. They already explained to me how orbits aren't simple. You go a little too fast, you fly out. You go a little too slow, you crash in. It's really complicated. How is this little tiny piece of crap figuring all that crap out? And then it's doing it enough to be able to do this figure 8 thing, which doesn't even make sense because you don't keep your distances right and your speeds won't be right. You have to be faster around this one and have to go slower on this one. I mean, none of it makes any sense. So how could there possibly be a balance that way? How could you make something durable? How could you make a piece of steel that way? With all that swirling crap. No chance. Anyway, And then you get into crystals, and this stuff has to be rigid. Crystals have to be rigid. They're in planes. Everything has to be in a place. It can't be stuff. So anyway, so they start off with this wrong idea that this stuff is moving in orbits, and then they make it worse, okay, in the modern era by just saying, oh, it's this blobby thing here and a blobby thing here, and the electron doesn't have any position. It just poofs. It poofs here, and then it poofs here, and it poof, 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 poof. Just a poofer. It's just what the hell? It's even, it's 9 million times worse in terms of saying that's going to glue things together, that poofing electrons. I mean, it's just so bad. And I'm just saying, if they were fair to Maxwell's drawings, they would recognize that no, this is a perfectly viable explanation. This idea of the attraction and the attracting force being balanced by repulsive forces, and just understand that's what holds atoms together, and that's what holds substances and compounds together. And there's just no reason to say we are absolutely sure, okay, that this stuff is popping in and out of existence, or whatever the hell they think it's doing, to create these, whatever they are, these blobs of space, these probability quotients, And the truth is, the whole thing is vibrating. So the point is that's what the temperature is. And like I said, even things that are well below zero, hundreds of degrees below zero, are still very warm in Kelvin. So they're still hot, and they're still vibrating. And that's all this represents, is that yes, this stuff is all doing this. It's not staying in one place, but it's physically actually in a place at every one tiny parsec of time. It's in a place, and it is being affected by real force in the universe, and the real force is affecting and causing its motion. It's not just moving for the hell of it. It's moving because it's being pushed constantly. Pushed this way, then pushed that way. And both of those are pushes. Neither one of them is a pull. The absence of a push is what we call a pull, but that's all it is. It's the absence of a counter push. All right. You don't pull on doorknobs. You don't pull on ropes. I mean, you don't. You're pushing on the rope. So if I have something and I'm pulling, no, I'm not. I'm pushing this way on the rope. It's always there to be seen. And they won't even take a little bit of that and say, let's explore some of that, and be fair to the argument and say, okay, yes, realistically, we could say every single pull I can show you how it's really a push. And that's just a fact. And it's hugely important to get this foundational stuff reasonably right. And they won't concede that they really don't have enough evidence to say this is the truth, this is the only truth, this is the only possible explanation, but they say it all the time. They say no particle theory can explain the double slit, when, yeah, it can. All the time they just say this stuff. That nothing can be explained with any other theory but their own. God is the only answer. Their God, their Holy Ghost, their silly story. And you show up, and for 10 years you make these arguments explaining how, well, these other theories do work. These other explanations are possible. They're contenders. Okay? And you just won't let them fight. And that's what is revealed. If you try to suggest they're wrong, they'll kick you off whatever forum there is. Okay? They'll silence you whenever they can. And they'll downvote your videos. They'll do whatever they have to do to silence any contending argument from getting any fair airtime. They will never show up for a debate and actually argue the arguments on the table. They'll just keep arrogantly stating, we have 5 million satellites that did 5 million experiments and they all prove us right. But they won't explain, they won't allow you to challenge any of that crap. They'll just say, LIGO did it. Yeah, okay. They bounced the beam of light off mirrors 1,600 times. Yeah, that didn't have any effect. That didn't break the ruler at all. Just so. When the facts are revealed, they won't even concede that, yeah, they should be doing better than that. I mean, it's just an absolute fact that when Eddington's journal was published, okay, I guess nobody read it, and it's just a story about how the experiment was a complete failure. 10% of the data quality. You got 10% of what it was hoping for as an image. It wasn't just a little bit shitty. It was incredibly shitty. And that image proved Einstein right. I mean, that's the joke of all this thing called physics or science, is they say this thing is this pristine experiment worthy of everybody's attention, and it's not worthy of any attention. They do little cart experiments, and they don't concede that, yes, we put the tiniest, smallest metal wheels on the cart we could find, because we want to store as much energy as possible in the rotation of the axles. That's the way you can store a lot of energy at axles, is to have little tiny wheels. That's the way to do it. All right? And then you have an air track, and you say, oh, it's this perfectly neutral experiment when there's no external forces, and it's just the carts floating on air. And then you can make the argument that, oh yeah, I've seen those boaty things floating on air, and they're doing this all over the frickin' place. They're going sideways, they're going all kinds of directions, because anytime any air escapes, it's essentially a little thruster that causes it to jerk around. So hardly impossible to be a flaw in that experiment, is there? Oh yes, it is possible that you've introduced some other energy. When you crash two cars, they could possibly tip up, shoot air at each other, and end up leaving with more energy than they had in the collision, because they've now got a little extra air boost. Facts. Those are facts. They're not made up. They're not non-coherent to reality. They're perfectly stating the fact that you're pumping a bunch of energy into the experiment, and that you are the one that has to demonstrate that all of that energy is neutral. Having built one myself, and I did it a little different. I did PVC pipe, pumped the air inside of one pipe so another pipe floated around it. And you could just see it was constantly doing this shit. Okay, it was constantly, being affected by the neutral system. Okay, that wasn't perfectly neutral. Tiny irregularity, tiny tip, tiny imbalance throws the whole thing off. All right, and then a lot of these arguments, I might as well just throw it in just as a gratuitous point. That every one of these foundational subjects they messed up, and the MV squared one is just such an obvious. Why the hell are you doing that? Why are you putting this square on here? Oh, it's right on the thing. There's no good reason. It's not amperage and voltage squared doesn't equal wattage, so it doesn't work in other cases. Why do you think there's something special about going twice as fast? Somehow that's 4 times the energy. Why would you even think that's possible or true? And then you have something as so obvious as the balance, right? You make a balance, and you put a 1 mass at 2 distances and a 2 mass at 1 distance, and it balances perfectly. This moves up and down. If I perturbate it, if I force it to move, put a little energy into it, it works like a pendulum. It restores the energy. It keeps it for quite a long time, and it will balance in the sense that this object will in fact move twice the velocity. Okay, and this object will move 1v. And in fact, it's just proving to you that the momentums are balanced, not anything called an MV squared. And I have to make these arguments for 10 years? You won't concede? Well, yeah, that's a pretty good piece of evidence. We should explore this. If we're going to claim that this MV squared thing is real, then we should be able to show you. So they can't show you in a ballistic pendulum ever. So no ballistic pendulum in the history of mankind has been able to collect anything more than the meager, tiny momentum. So you put a bullet in with 2,000 joules of kinetic energy, but only 2 joules of momentum. And what do you get out? 2 joules of momentum. You don't get the 2,000 joules of kinetic energy. Gone. All right. And every single experiment, like I said, demonstrates its failure. And they just keep claiming it's the truth. And then calling it science. And, I just sit here and wonder. Because you would think after all these years of making these videos, a few people who really care about science, really care about the logic behind it, the integrity of it, would say, yeah, these are pretty good arguments. We should really force the science to do a little better. Okay, the Eddington experiment isn't good enough. And the fact that you haven't done it from space when you don't need an eclipse, it's 400 times better resolution. That is, you can see 400 times better. It's a 400 times better picture. You can't even imagine a 400 times. I can't even imagine a 400 times bigger screen to be looking at. 400 times. Huge advantage, right? You don't need an eclipse. 400 times better resolution. It takes 5 minutes. And they haven't done it from space. Who believes that's credible physics and credible science? And you people are going to tell me you're honest people showing up here to be an honest thinker, and you think you can just mock me and just say, all the arguments you made are just rubbish and garbage, and we've proven them all wrong somehow we've proven that Eddington didn't write in his journal that he got 10% of the data quality, when no, that's exactly what he wrote in his journal, assholes. I mean, who's doing the lying? All right, who's honestly pointing out something, and you're saying, I will not be led to the water and I will not drink it. And that's all you're saying. You're just saying, God is God. I believe in my religion. All right, and I will not listen to your evolutions, your Satanistic evolution. I won't listen to any counter theory. Instead, I'll just play little mocking games. And that's going to be the historical record. I'm just saying the record is right here. What defense is there of the human race when they show up here and all they can do is naysay, nitpick, and ignore? They can't come close to making anything called a rational fucking counter-argument. 2 pounds weighs 4 pounds. That's their counter-argument. Yeah, no, it doesn't. Oh, shit. All right, anyway. So I'll make a few of these on the different subjects. But I mean, look, they got it all wrong. Wave particle, completely wrong. Interference, wrong. Forces don't interact with forces. I mean, it's, it's all so wrong. Every single premise, underlying foundational axiom of physics is rubbish. Jeez. All right, anyway, so till the next time and such and so forth. And whatnot. I mean, some of religion gets something right? Once in a while, religion says something nice, like, do unto others as have others do unto you. Well, there's some perfectly good logical statement. So now and then it poofs something reasonable. So I'm not saying their physics is incapable of saying anything sensible. But they haven't defined a single cause correctly. You should do unto others as others do unto you, because it's logical, not because some God said so. And you should believe in LEDs, not because they told you it's made out of bubicles, blah, 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 entangled jibber jabber. You should be able to understand that now the cause is probably something perfectly reasonable. All right, till the next time and such and so forth and whatnot. Hate this planet. I mean, really, there's so little evidence that there's any decency in the nature of human beings. I'm just saying, what is it? What are the average here? What are the odds? Let's just say there was 5 new viewers per video. Because YouTube totally keeps this stuff from being seen. Even those 5, none of them have the integrity to say, yeah, those are good arguments. Yeah, sure. Good arguments. They really should research this stuff. They should have crashed some cars. They should have done these experiments. They should make the lever launcher. They should do this. They should do that. They shouldn't be doing experiments with plastic cars with little tiny metal wheels. Yeah, they should come up with a real mechanism to measure transfers of momentum. And they don't. again, the simple experiment you can do is this: the Newton's cradle, the 3 mass and the 1 mass. All right, they have this silly notion that I put the 1 in with 100 momentum. It gives the 3 mass 150, and it bounces back with 50. Yeah, and then 50 and 150 collide, and only 100 pops back out, and it does that over and over again. So at one moment there's 200 momentums in the universe. The next moment there's only 100. Then there's 200, and then there's 100. You know, it doesn't make any sense. You can't pay people to take their high-speed cameras, all these people with their slow-motion cameras, to do those kind of tests. You can't pay them. They won't take your money. All right. Just too ridiculous.